Hello, hello everyone, and today we'll be solving the first Leetcode problem called TwoSum. It is a problem that is the most popular on the Leetcode. Like, as you can see here, almost 2,000 people are solving it right now. And it requires the basic knowledge of what is the array and how to use loops in order to use the first type of solution, like brute force solution. The brute force solution is the solution that counts up all the variances that can be possible for the answer, for the output, in order to get the correct answer. We will cover up the solution as well, like using the nested loops and visualizing it. First, we will visualize it, understand it, and then we will go to the coding. And second part of our video will be using the data structure called HashMap. I will explain what is the HashMap, what are time complexities, and we will analyze by time complexity and space complexity both of our solutions. So don't be scared of these new words that may be scary and or terrifying for you. We'll just cover up everything later. So let's go to coding and understanding the problem. So first, let's start with understanding what is an array. Array is a contiguous collection of elements that has indices for each of its elements. It is zero indexes, so the indices starts from 0. So basically, as you can see here, the first element with number 2 has index 0. The second element with number 7 has index 1, and etc. Let's look into the example of the problem. Here we have 5 elements and indices from 0 to 4, and our goal is to find two numbers that sum up to 5. Those two numbers, as we can see clearly here, are 3 and 2. So basically we should return the answer 1 and 2. So let's look how we can approach this by brute forcing. Here we should create a pivot index that will set a pivot into the first element from the left, and second moving pointer j that will iterate throughout the rest of the array. So basically nums0 plus nums1 here is equals to 11. It's not correct answer. Let's update the index j to 2 because our pivot is set until j reaches end. So here we update j into the second element. So right now it's 8 plus 2 equals 10. Also not correct answer. Let's move. We again update to j equals 3. 8 plus 1 equals 9. Also not correct answer. Then we update to 4, the last element. Again, 8 plus 9 equals 17. Now we should update j to this element and set update I mean to this element and set j into the adjacent to I. So here. So let's look. Right here, we update it to 3 and j we set to the adjacent element 2. So basically this is the correct answer, yeah. 3 plus 2 equals 5. So our algorithm is, we should always set a pivot point I and iterate throughout the rest of the array in order to find the correct pair. It will be done by nesting two loops. First loop for the pivot, second loop for the iterating pointer. So now let's move to the coding. So now let's realize our idea. We should create the first loop integer I that goes through the whole array, and we should update. It will be our pivot. Let's comment it. Pivot index. Then the second nested loop will go through the rest of the array, and it will always be adjacent to I, so it will be I plus 1. And we should update it as well. And we should create a condition. If nums I plus nums j equals to target, then we simply return their indices. And that's all. Where is pivot? That's pointer. So let's run. Oh, yeah. We have here the problem that we should return the empty array. So yeah, all the cases are done. So basically, once again, I will explain. This loop will go through the whole of the array once, but this loop will go once for the whole of the array for each of these elements. So it means for n number of elements in the array, this loop will go also n times. So basically it's n squared times of operations of comparison of this. So I'll explain later what is the n squared, how to compare, what is the space complexity. So our first solution of brute forcing like 2 arrays is done. Let's submit. Yeah. So basically it's not so efficient as I said, like for runtime it beats only 30% of solutions, but for memory it's pretty good. So let's visualize the second part of the solution. So right now for the solution with a hash map, we will understand what is a hash map. Hash map is a collection of elements with key and value pairs. So basically it's type of the data structure of the hash table. For each element in the array, we assign the value of index. Like it will be the pair, like key and value. And the key feature of the hash table is that we can access any element instantly, instead of waiting iteration by iteration to get the elements. So basically, it will be, the value will be index, whereas the key will be the value, like array and index. Our solution is that we will store first all of the elements in the hash table, like that. Just imagine that this is hash table. It will be like 8 and 0. This is the first, this one, because the element is 8 and its index is 0. Then 3 and 1, 2 and 2, 1 and 3, and 9 and 4. After storing it, we will create a complement. What is a complement? Complement is target minus array index. So basically we know that target is sum of nums I plus nums j, right? So basically nums j is our complement. And after storing all the elements in the hash map, we will find the complement. So basically, if complement exists, we just return this value, return value. Once again, after storing all the elements in the hash table, hash map, we just solely iterate through the array, like from index 0, 1, 2, 3, 4, and check for each index if target minus the element, like here, for example, 5 minus 8, it is less than 0, so we do not consider 8. 5 minus 3, it's 2. And there exists 2 in this array, because we stored it in the hash map. So if the 2 exists, we just look into the hash map and get the value of 2. Here, the value of 2 is the second index, 2. And we just return the index of 3, which is 1, and return from the hash table index of the second number, that is 2, which has index also 2. So basically, this method creates a better approach because we just save our resources instead of doing the in the brute forcing approach, checking all of the variances. We just check whether for this element exists the number that their sum will give us the target. Like, for example, if it was 2, we would take the 3. If it was 1, we would take the 4, but there is no 4. If it was 9, but it's less than 0, like 5 minus 9 is less than 0, we do not even consider the 9. Let's now turn to the coding part. So basically, first we should create the hash map. Here is a prototype of the hash map. It's an unordered map in C++, which accepts 2 types, key type and value type, and also variable identifier. So basically, let's create an ordered map. Our key type is integer because the value of the key is the integer from the nums array. And our value type is also integer because it's index. Let's call it numbers map. Now we should add all the values from the array to this map. Let's do it. So to add, we can use the square brackets, and we know that we should assign the index for the value. So let's write right here, and the key will be the value of the nums array, right? So it's basically nums I. Like, for example, if nums I equals 2, then I equals 0. So it will be 2 and 0, and etc. For integer I equals 0, I is less than nums size, I plus plus. Why I have done it? Because now we should create the iteration in order to check whether the complement exists. We create the complement, which is a target minus nums I, and we should check whether it exists in our hash map. Numbers map. We should count how many of complement exists. If it's not 0, then we should return this value. And also we should add the constraint, that the complement is not equal to I, because as you can see here, we cannot use the same element twice. So and now we should return I and numbers map complement, and return also empty array in other cases. Let's try. So yeah, basically it's working. And how it's working? So after saving up all of the values, let's look into the example number 1. It will be 2, 0, then it will be 7, 1, then it will be 11, 2, then it will be 15 and 3. We look up for the complement. First, our I is 0, and our complement equals to target minus nums I. So target is 9, and our complement is 7, right? Yes. So when we call the method count complement 7, it comes to the value of this and returns the indices 1 when we call it by when we access it by square brackets, like complement 7, it will be 1 here. And also we check if numbers map complement is not equal to I. So basically our I is 0 and our numbers map complement is 1. So it's also true. So basically we return the answer 1 and 0. And it happens for each of the elements once, not n squared times as it was before in the brute force solution. Now, after analyzing this code, let's move to the space complexity and time complexity of our both solutions in order to seek out the most performance and most efficient algorithm. So let's look. It's our second approach, it's our the first approach. For the second approach, we have here first the loop which iterates throughout the whole of the array n times. For example, the array size is equal to n, like 4 elements, 5 elements, and it will iterate through the whole array n times. Because we have here integer I equals 0, I is always a num size, I plus plus. So basically this structure means that it will iterate from 0 to the num size minus 1 times, and we'll create and we'll do this operation like numbers map nums I equals I. Then we have the second operation, also the same loop that will iterate n times due to the condition here, and it will do the same number of operations. So basically our code will do 2n operations for n size of array. So basically it's O n, like f of n equals 2n for n times of operations. But in big notation, we take only the variable, only the biggest variable. So it's just n. So for n size of the array, we will do in average n operations. Let's look at the first approach. The first approach in terms of time complexity does first all n operations for the outer loop and all n operations for the inner loop here. But for each I, it does all n times operations. So it's basically f of n equals n times n times operations. So it's n squared. So for n size of array, we do n squared operations. So for example, if array was 1000 elements big, we would do 1,000,000 operations. Whereas here, in the first approach, for 1000 size, we would do around 2000 operations, basically. Now, let's move to the space complexity. The space complexity in the second approach is ON. Why? Because here in this loop, we add the value from the array to our hash map, basically occupying the memory of the computer and creating new elements. So for n elements, we create more n elements in the hash map. So basically it's ON. Whereas here, we do not create anything. We just have here the stationary pointers I, stationary pointer j, that iterates throughout the array, and we do not create anything. So basically it's constant number of created elements. Like maybe it's even 0, but not 0 because we have integer I which was being created as a pointer in integer j. So it's 2. So basically it's O1. O1 means that it's constant number of operations. Constant number of operations. Let's sum up. The first algorithm, in terms of time, it's all n squared. Whereas in terms of space, it's all 1. Whereas the second algorithm, in terms of time, is on, and in terms of space, it's also on. So basically, by time, the second algorithm is very much better than the first. And by terms of space, the first algorithm is better than the second one. But mostly on Leetcode, we focus on time complexity. So basically, the second algorithm is more structured, more approachable, and less. Now, let's move to the conclusion. So in general, today we have covered up two solutions. First, using the data structure, and the second, like brute forcing solution using two nested loops. Talked about complexities in terms of efficiency and number of operations, visualize the problem, understand the problem, and coded the problem of the two sum, and just had a great time solving this problem together. I will also create the video related to the complexities and more detailed video about HashMap and data structure of hash table itself. So if you like the video, please like and subscribe and wait for the new videos to solve. It is the first video of the Leetcode problem solving, and I would upload many more if you like this. And I also wait for your feedback in order to improve the content creation. So until the next video, bye.